Math 3 Lesson Summary Video, The Irrigation Situation. This lesson is a practice understanding task, which takes concepts you have been working on and applies them to new situations. The purpose of this lesson is to focus on the measure of an arc of a circle, not as a measure of length, but as it relates to the measure of a central angle. The setting on the sprinkler with the full circle symbol indicates the sprinkler will sweep a full 360 degrees and keep rotating. The setting with the half circle symbol indicates the sprinkler will sweep around 180 degrees and sweep back to its original position. A third symbol indicates the sprinkler will sweep through it looks like 1/4 of the circle. So we're going to go with it's going to sweep through a 90-degree angle before returning to its initial position. How much of the circle does the sprinkler sweep when it is set on the full circle? Well, if this is all colored in, it does look like it would be the full circle. And how much of the circle does it sweep on this setting? Well, I'm going to go with it probably looks like half of it. And this is 1/4. So sketch a symbol you would expect for a setting that would sweep 1/3 of a circle. All right, so if we're going to have 1/3 of the circle, if we have the circle, we would need about 1/3 of the pie. So something kind of like that. Obviously, I didn't measure that with the protractor, but that looks like about 1/3. It's not half, it's not 1/4, it's kind of somewhere a little bit more than that. Sketch a symbol you would expect to see for a setting that would be 2/3 of a circle. Well, I think it's going to look a lot like that, except I want this piece of it instead of that piece of it. So if I kind of do the same thing here, but this time I want the 2/3 part instead of the 1/3 part. That's 2/3 of the circle is filled in. So all of those fractions we did back in the 4th and 5th grade will definitely pay off. Now, the mathematical term for the angle that the sprinkler moves through is arc measure. The mathematical term for the distance around the curve part is arc length. So this is going to be a place where we really need to focus on vocabulary and where the English language sometimes gets us into trouble. Arc measure and arc length to a lot of people from an English standpoint sounds like the same thing. We're using words that mean the same thing, but in math they mean something very different. Arc measure is a degree. It's a measure of an angle. Arc length is going to be some kind of linear unit like centimeters or inches or feet or meters, something along those lines. It's a linear unit of measure. So we're talking about an actual distance. And so these are measured. They're two different measurements for the same thing. So if we're talking about a piece of a circle, not the whole circle, a piece of a circle we call an arc, all right? If we want to find the arc's measure, that's based on an angle. But if we want to find the arc's length, that's if we stretched it out and put it up against a ruler, how long is that piece? So those are two different things. Now in your task, you have a table. And so when we are looking at these pictures, we want to fill out the table with what would be the arc measure and what would be the arc length. If we look at the full setting going all the way around, and we had 3 different sprinklers with 3 different radii, and we want to compare kind of what's going on with those sprinklers. And so if I go all the way around 360 degrees, we generally don't refer to that as an arc. We actually refer to that as the circle itself, or if we're looking for its length, circumference. So we do need to remember some of our formulas from back in the day. So to get the circumference of a circle, if you don't remember, it is the diameter times pi Or if you have the radius, it's 2 times the radius times pi. And that's going to give us the whole distance all the way around. We also know that angle-wise, all the way around a circle is 360 degrees. Something that's interesting to note is that angle-wise, this circle's measure is going to be the same as this circle's measure. Their measures are the same because they both go 360 degrees, but their lengths are very different. This smaller circle has a much smaller radius, so its circumference is going to be much smaller than this big circle, which has 3 times the radius, and so its circumference is going to be 3 times bigger. So measure for these two circles is the same, but length is very different. If we look at the half setting, we don't really have a formula to find the arc length halfway, but if we know its circumference and we know it's half of it, then we can just use our circumference formula and take half of it. Again, we're going to notice that all of the circles have a measure of 180 degrees because to go halfway around the circle is 180 degrees. So all 3 of these arc measures are going to be the same. But again, our lengths is going to be different. This one is visibly much smaller than this one. And in fact, if this radius is 3 times as large, then the length of this arc is going to be 3 times as large. Now, make a sketch of image C. Notice they gave us the 2 settings here, but we didn't get the quarter one, so we would have to draw that ourselves. If I'm just going to use the picture that I have here for the quarter setting, I would want to take half of this one over here. So I'm going to get rid of this piece of the picture, and so this sprinkler is just going to be getting this one quadrant wet. So if I just wanted to sprinkle that one quadrant, it would look something like this. Again, notice that all 3 of those arcs are sweeping 90 degrees. But again, their lengths are quite different. One of the big takeaways for this lesson is to notice that arc measure is found by the central angle associated with that arc. The beginning of the arc and the end of the arc, if they are connected to the center of the circle, that angle is the central angle. And that is how we measure an arc. That is its arc measure. But an arc length is its linear distance. And we find this as what piece of the circumference is it? So arc length is a piece of a circumference, and arc measure is a degree based on its central angle. We also notice that the arc length is proportional. We love to find things that are proportional because then we can just set up proportions and solve proportions quite easily by cross multiplying. Specifically, it is proportional to the arc measure. So the arc length in comparison to the circumference is going to be that same proportion as the arc measure is to 360 degrees, is to the entire circle. So those are proportional to one another.